Okay, so we're looking at chapter 7, and we're dealing with the Pythagorean theorem. So c squared equals a squared plus b squared. And this has to do with the acute and obtuse and a right also. Does anybody remember why I had you write it this way and not this way? There was a long time ago when we first started doing these, I made a big deal about not writing it like this. You remember, Olivia? You remember? That's why we do it. And you can always work in this way. So to do one with a square root, this is actually number 11 from that page that you did last night. Now my favorite. The main thing here is that square root. You need to know how to deal with that so that you can understand if you have a triangle, which one of these is going to be the hypotenuse, all that kind of stuff. So we need to break this down so it means something to us. So this is 5 times the square root of 26. That's what this problem is. I don't know what the square root of 26 is, but you can put it on your calculator and press the square root button and get us an approximate answer. So Pedro, what's a rounded one is 5 point what? I'll just do that. And if you multiply those together, what do we get? 2545? Yes? Okay, so that means this doesn't work, did it? Oh, it does. It's greater. Okay, everything works. 36 is still greater than 25, so we're still good for a triangle. So now I'm going to come over here and write down my formula for my Pythagorean theorem. This was just the work to know what this is. So we know what our, which one's bigger, and to check to see if it's a triangle. So now that we know it's a triangle, I'm going to put 5 square root of 26 squared. Why did I put it? Because it's the biggest one. Isn't the 25.45 bigger than the other two? And then I'm going to put 17 squared, 19 squared. Now, I have people ask me, why can't we put the 25.45 in there and square it? If you do that, you have made it so you will not be able to tell if it's the right triangle. Because to be right, both sides have to equal each other. And if you have rounded this number, which is what you've done, when you change a square root into a decimal, you have rounded it, which means it is no longer exact. You are now going to get a rounded answer. And that rounded answer is not going to make you get a right triangle. It's going to have some weird decimal. And you're going to look and go, oh, that doesn't equal that. And you're going to put a greater than or less than in there and get it wrong every single time. So what you have to do is use this. And that's where I come in today, talking about square roots. So I'm going to take my red, and we're going to talk about what this 2 means. This 2 means to write this twice. That's what I'm going to do. Anybody notice that I put the time signs between the 5 and the square root of 26? The time signs are there whether you see them or not. They're physically there. So that times is there equals, and I need a volunteer to tell me what the 1717 is. 289 and 1919. 1. So over on this side, that's going to be easy enough. So what is that? 10, 5, 650. This came out to be 650 over here. But this problem I need to work. That is a 5, see the 5, times another 5. Well, that's 25. If you look up here, see this 5? Isn't it 5 to the second power? That's where the 25 came from. Then down here, this square root of 26 times the square root of 26 is a really big number. Now, Elijah's going to tell me what it was. What is it? Oh, no, square root of 26 times square root of 26. What's 26, 26? Okay, 6, it's only 676. Okay, 676. But what is the square root of 676? Right? So what you need to learn is that when you multiply square root by that same number, see these two are the same, but look what comes out. It turns out to be just that number. So down here, those two square roots of 26s are really a times 26. Notice the square root is gone. Square root is gone. And now I can multiply 25 times 26 and get 650, which is what this is, which means, because that's a whole number 5, and that's a whole number 5, and that makes 25. 5 times 5. Agree that a 5 times a 5 is a 25? Okay, well, and the square root of 26 times the square root of 26 is really 676, but the square root of 676 is 26. So that's why you don't want to use a decimal. If we put a decimal here, we would have gotten some weird decimal here, and we would have gotten some other number than 650, and we would have not known it was right. Okay, so here's our problem. We first need to decide if this is even a triangle. So I need to find out what 3 squared of 11 is approximately so I can compare it. So how do we do that, Maddie? Okay, so 3.31 times 3. That 3 is this 3. The square root of 11 is approximately this. If I multiply those together, what are we getting, about 10-ish? What is it? 9.93? 4? Well, with what I have up here, it's got to be a 3. So I'm going to unpause and go, look, I have a 3, a 9, and a 9.93. I know which one's the hypotenuse, but first, let's make sure it's is it a triangle? Add the two smalls, 3 plus 9, you get 12. Yep, we're good. It's a triangle. Is that the two smallest? You take your two smallest. It's like little stick, big stick. If I add the two littles together, can they reach this? That's why this one wouldn't be a triangle, because these two add up and they're too short. We need numbers to be long enough to be bigger than this stick. So we are going to get rid of these guys. Hopefully you're working ahead. So now that I know I have a triangle to check off, I can come over here, use my Pythagorean theorem. Preston, which one of the numbers is going to be the C? Which one of these? Is the 3, the 9, and the 3 squared root of 11? Which one's the C? You said it, but I couldn't hear you. So I'm going to put 3 squared root of 11 right here and square it. 3 squared plus 9 squared. You have to know how to deal with this, Lauren. Thank you for asking. So here, I'm going to go 3 times square root of 11 times 3 times square root of 11. I'm writing it out the long way. If you figured out the pattern here, you do not have to write it out the long way. If you already know this is 9 times 11, which is 99, awesome for you. If you don't, I'm showing you why. So I got a 9 here and an 81 here. These 3's multiplying give you 9. Those 2 multiplying give you 11. Where did that 11 come from? Tyler, where did the 11 come from? If I multiply those, I get this. And the square root of 121 is 11. That 11 is this 11. There's no reason to do, see, look, square root of 11 times square root of 11. The answer to that is 11. So that's 99. This is what, 90? So we got to put a greater than symbol in here, which means this one's up 2. I'll do one more. Right, so this, we need to find out what this is so we can compare it. So 3 times square root of 40 out there, somebody? 6.3. So we'll multiply those together and get 12.64, maybe? No, 18. Oh, I'm way off. I was doubling it. 18 what? So now we can compare 12, 15, and 18.96. Those are our 3 numbers, approximately. We know this will be the hypotenuse if it is even a triangle, so I'm going to check my two smallest. My two smallest are a 12 and a 15, so I'm going to add my 12 and 15. We have 27. 27 is definitely greater. So check, I have a triangle. I'm practicing that procedure only because you're going to have some problems that all you have to do is check to see if they're a triangle. So we're just practicing it as we go. So c squared equals a squared plus b squared. And I'm going to plug all this stuff in. Which one of these, Jimmy, is going to be your c? This one. Right? And how did you decide that? Right, mu was larger because it's 18.96 approximately, which definitely beats the 15 and the 12. So I'm going to put 15 here, 12 here. 225, 144. Over here, does anybody, so she already knew it's 3 squared, that's the 9, and square root of 40 times square root of 40 is just a 40. So it's 9, because that's the 3 squared right there, times that squared is going to get you 40. So that's what, 360? Over here, what, 369, which is definitely a little bigger. We have a less than symbol. If you have trouble with your less than and greater than symbol, remember that a less than symbol looks like the word less. Look, L-E-S-S, I'm a less than symbol. So acute. Okay, so we have 4 square root of 21, comma 25, comma 31.